Hello to everyone who is just now joining us. My name is Allison Cleaver. I'm leading the Stoichiometry Hour for Chegg's Office Hours. We have sessions all week, so I encourage you to look at what your classes are and see if there are any sessions that apply to what you're taking. If this is your first session, welcome. And if you're back from another session, thanks for joining us. I have been a TA for chemistry. I helped tutor chemistry in high school, and then once I got to college, I've tutored as a TA in organic chemistry, regular chemistry, and calculus. So I'm here to answer your all's questions. I encourage you to ask questions throughout this event. That's what it's for. I want to answer all of your questions and help you in any way that you need. I've prepared some questions for us to start with, but when you have those questions, don't forget to add them in the chat so that I can answer them for you. All right, so we are going to start out with molar mass. Molar mass is a really important concept of chemistry. It tells us how to get from grams to mole of all types of different substances. So we are going to start by finding the molar mass of C7H12O2. I don't know the chemical name for this, but if you do, good job. You can put it in the chat if you know it. But to find molar mass, we are wanting to find the grams per mole for the whole molecule. So the way that I like to do this is I like to divide up all of the different atoms within that molecule. So in this case, we have carbons, hydrogens, and oxygens. So when I look at my formula, I see that there's 7 carbons. So I'm going to solve this kind of like a multiplication problem. I have 7 carbons times whatever molar mass is on the periodic table. So when you find carbon on the periodic table, there's going to be a number that tells how much one atom of carbon weighs. So that number is 12.01, and I'm going to put 7 times 12.01 in my calculator, and I will get 84.07. The reason this is 7 times 12.01 is because 1 mole of carbons has 12.01 grams, and there are 7 moles of carbon in my 1 mole overall. So I do 7 moles of carbon times 12 grams per mole, and I get that 84.07. Now I'm going to do the same for hydrogen. So I have 12 hydrogens, and I look on the periodic table and I figure out what that molar mass is, so the grams per mole, and I determine it is 1.01. I'm going to give you guys a little bit of time to put that in your calculator. If you know the answer, type it in the chat or feel free to ask any questions that you have. Okay, when we put that in the calculator, we get 12.12. And again, that's because there is 12 moles of hydrogen in this overall molecule, and each mole is 1.01 grams per mole. So I'm multiplying the two together. Last, I'm going to look at this oxygen, and there are 2 moles of oxygen in my overall compound. So I go to the periodic table and I find that molar mass for 1 mole of oxygen. If you can find that and you see that in the periodic table, let me know what it is in the chat. And I'll give y'all 5, 4, 3, 2, 1. That is 16 grams per mole. So again, the 2 comes from my molecular formula, and then there's 16 grams per mole, which is what we get from the periodic table. So there is 32. When we put 2 times 16, we get 32. Our final step of finding this molar mass is to add all 3 of these together. So we want to add all 3 because we want to find the overall mass of our starting compound. That's why we're adding all together. We found the individual mass components of each type of molecule in our overall compound, and now we want to find that overall mass. So I'm going to give you guys a few seconds to plug that into the calculator. Let me know what you guys get. And let me know if you guys want more practice with these finding of the molar mass. I know they're a little bit complicated once you start with them, but once we do some practice, I think it'll be a lot easier to understand. So I'm going to give y'all about 10 more seconds. Remember, type that answer in the chat once you get it from your calculator, or if you can do it in your head, that's great too. 5, 4, 3, 2, The answer is 128.19. And we always have to include our units. Does anybody know what the units are? The units are grams per mole. So we have determined that this compound, C7H12O2, has 128.19 grams per mole. If that makes sense, let me know in the chat. I would love to hear from you guys. And just a reminder that this session is for you guys to ask questions. That's what I'm here for, is to answer your questions. So please, please type them in the chat. We are so happy you're here. If you're just now joining, thank you for coming to the Chegg Stoichiometry Office Hours. We have sessions all week, so I encourage you to join the ones that match your classes and courses that you're taking this semester. So from Zaid on TikTok, we have, do the second one, just do grams given over molar mass to get moles. That is good. Let's see. I think that's a good guess. Definitely tell me what you all think for these upcoming questions. So we have 72.02 grams. And our question is, how many moles is 72.02 grams of C7H12O2? So we always write down what we're given to start with, and we are given 72.02 grams. And then we want to get to moles. So just like Zaid on TikTok said, we're going to do grams given over molar mass to get moles. And the way we know that is that we want what's on the top to cancel out with what's on the bottom so that we can get our final answer. Since we're ending with moles, we want moles to be on the top. This is the factor label method for stoichiometry. I talked a little bit about it last week, but if you're just now joining, when we are doing stoichiometry, we want whatever's on the top to cancel out what's on the bottom. So we switch our units so that they do cancel out. And from problem number 1, we figured out the molar mass. Actually, that's what that question was. So just like Zed on TikTok said, we're going to do our mass given over our molar mass. So 128.19 grams per mole. And the number always goes with what is on top. So the number always goes with grams if grams is on top. If centimeters is on top, the number always goes with centimeters. And then our bottom number always just gets a 1. And then I like to say we multiply the top and we divide the bottom. So writing this out in simpler math terms, this is going to be 72.02 over 128.19. Good job, Zed. Put this in your calculator, and I'm going to give y'all about 20 seconds to type it in and let me know what answer you guys get. Got about 10 more seconds. Don't forget to let me know what answer. All right. 3, 2, 1. Our answer is going to be 0.5618 moles of C7H12O2. If that's what you guys got, let me know. And as a reminder, we talked a little bit about this last week, but we have to follow sig figs in stoichiometry. And so when we started out with 72.02, which has 1, 2, 3, 4 sig figs. So our final answer has 1, 2, 3, 4 sig figs. So we have to have those sig figs match up. We have a question from Lawson on TikTok. Isn't it meters over moles? That's very close, but this problem doesn't really take into account meters. There are some questions that have meters and moles together, but since this problem doesn't ask about meters, we aren't really worried about that, and we won't have meters on top for this problem. As a reminder, please ask any questions you have. If you guys need any homework help, type those questions into the chat. That's what I'm here for. I want to answer all of y'all's questions so that we can have a better understanding of stoichiometry and chemistry. If you're just now joining us, welcome to the live stream. I'm so glad you can make it. This is our CHEG Stoichiometry Office Hours. I encourage you to check that schedule in the top left for all of our office hours throughout the week. All right, now we are going to go on to problem 3. And remember to ask those questions so that I can answer them for you guys. We want to convert 42 millimoles of oxygen to molecules. So this is going to take a few steps. And it's going to probably be a 2-step. We need to know an important number that's very important to chemistry and stoichiometry. It's called Avogadro's number for this problem. Does anybody know what Avogadro's number is? I'm going to give you all about 10 seconds to tell me what that number is. It's very, very important. So if you don't have it memorized already, I definitely encourage you to get it memorized. It's going to help you in your chemistry courses a lot. All right, we have 3, 2, 1. That answer is 6.02 times 10 to the 23rd. And that really doesn't have a unit with it. It's kind of a count. It's a count from, it can go from moles to molecules or moles to atoms. And there's a few other things, but those are the two that we'll see most often. But we want to start, we're starting with 42 millimoles and we're getting 2 molecules. Good job, May Loon on TikTok. That is absolutely correct. 6.02 times 10 to the 23rd. So with these problems, we always start with what we're given. In this instance, we're given 42 millimoles. And we want to get to oxygen. Does anyone have any ideas about how we would do that? I will say that this problem tricks a lot of students because they think that the oxygen is important, but we're going to see as we solve this problem that the oxygen actually doesn't matter. And a lot of teachers are going to put these types of questions on tests to confuse you and make you think that you need to know that molar mass, when in reality, we don't need to know the molar mass for this problem at all. But back to the problem, we are starting at 42 millimoles. In our first step, does anyone have any idea on what we need to do? I'm going to give you all about 5 seconds. 5, 4, 3, 2, 1. Okay, so first we need to go to moles. And the reason we need to go to moles is because we have this conversion that's going to get us to molecules in the end. But that conversion, that Avogadro's number requires us to be in moles. So our first step is we need to go from millimoles to moles. Does anyone know how we do that? If you know how, put it in the chat. Our second step is that we need to go from our moles to our molecules. So moles are on the bottom because remember, whatever is on top, we want to cancel out what's on the bottom. Good job, Mayloon. We do have to cancel moles. So moles on the top and moles on the bottom, and then we're going to end in molecules. And then Lawson on TikTok, you just got the whole process. Good job. She said we need to convert millimoles to moles and multiply by 6.02 times 10 to the 23rd. All right, so to convert millimoles to moles, we start with 1 mole on top. And we have to remember those conversions from moles to millimoles. If your teacher gives that to you, that is great, but my teacher made me memorize it. So if you have to memorize it, now is a great time to start. And I know that there are 1,000 millimoles in 1 mole. Now I want to go from moles to molecules. So to go from moles to molecules, I'm going to use that Avogadro's number, and I know 1 mole has 6.02 times 10 to the 23rd molecules. So now I need to solve it. I know, like that I said up here, I have to multiply the top and divide the bottom. So I'm going to end up doing 42 times 6.02 times 10 to the 23rd over 1,000. That's what I'm going to put in my calculator. I'm going to give you guys about 30 seconds to put that in and let me know what you guys get. All right, we've got about 20 seconds. Type that in the chat once you know what it is. All right, about 10 seconds. 5, 4, 3, 2, 1. Remember, type that in the chat once you get it. I see from a comment on TikTok from Lawson that it's 10 to the negative third. That is also correct. I like using whole numbers and no negative exponents. So that's why I do the 1,000 and the 1, but you could put 10 to the negative third for moles, and that would absolutely be correct. So our final answer is 2.5284 times 10 to the 22nd. If that's what you guys got, let me know in the comments if that's what you all got. And then there's one last step we need. I talked about sig figs earlier. I want to go back to those sig figs. How many sig figs should this answer have? I'm going to give y'all about 20 seconds to tell me how many sig figs should my final answer have, or is the answer that I have right now correct? All right, 10, 5, 4, 3, 2, 1. Okay, so since I start with 2 sig figs, my answer needs to end with 2 sig figs. So I need to round this to have only 2 significant figures. So my answer is actually going to be 2.5 times 10 to the 22nd molecules. Is everybody understanding sig figs? If you're not, comment in the chat and we'll do some more problems working on sig figs. It is very important for chemistry. Your teachers will test you on this. I know for my freshman chemistry class, if I didn't do sig figs right, then I got the whole answer wrong. So this is definitely something very important that you'll want to know how to do. And just as a reminder, I encourage you guys to ask those questions. Ask any questions you have about homework, about things you're learning. If it's about stoichiometry or chemistry, that's what I'm here for. I want to answer your questions. So type those in the chat so that I can answer them for you. And if you're new to this live stream, if you're just now joining us, welcome. Thank you for coming. This is Chegg Stoichiometry Office Hours. I'm Allison, and I'm trying my best to help y'all learn all about chemistry and stoichiometry so you guys can do really well in those classes. All right. Now we have how many molecules is 328 milligrams of oxygen? So I think that this one's going to take us a few steps. We're going to work through it slowly so that we hit all of those components. But if you have any ideas on how you start this problem, let me know in the comments. Or if you know just any specific steps or the whole thing, let me know how you would do it, and then we can check our answer. So the way that I'm going to start is I know that I need to go from grams to molecules. And whenever we're going from grams to molecules, we always need a middle step, and that is moles. So I know that for this problem, because I need that mole to gram and gram to molecule information, I'm going to need to know my molar mass. So who knows the molar mass of O2? If you know that molar mass, type it in the chat for me. We did an example earlier. I don't know if you guys were on for that, but we will work through another one again. But if you know that molar mass, let me know. So how I would do this is I know that O2 is what I need the molar mass of. So I've got oxygens and I have 2 moles of oxygen. Then I would go on the periodic table and I would see what is the molar mass of my oxygen? So looking at the periodic table, I determined that the molar mass of 1 mole of oxygen is 16 grams per mole. So then I multiply across because I have 2 moles of oxygen. So my moles would cancel out and I have 16 grams per mole. So I get 32 grams per mole of O2. Okay, I see from Lawson on TikTok, balance it first. I think you're looking at our problem 5, which we are going to balance. So good catch. So we have this molar mass for number 4. We have this molar mass of 32 grams per mole of oxygen. So we want to start with what we're given. We are given 328 milligrams of O2. Then we have this conversion factor right here of 32 grams per mole. Well, my answer right here is not in grams. So I know my first step is going to be to get it to grams. I put milligrams on the bottom to cancel out milligrams on the top. And we have that conversion factor. So it's 1 gram is 1,000 milligrams, or you can put 10 to the negative 3 for grams, whichever you prefer. And then I'm wanting to get to molecules, and I determined earlier that to get to molecules, I have to go to moles first. So now I need to go from grams to mole. Lucky me, I found my molar mass earlier, so I already have that conversion, and I know 32 goes on the bottom and 1 on the top because the number always goes with what's on top. Then I can cancel out my grams. Last but not least, I want to get to molecules, and I know that I have that secret Avogadro's number, so I can do moles to molecules. And what is that number? If anyone remembers, let me know. It's 1 mole is 6.02 times 10 to the 23rd molecules. So I'm multiplying the top, I'm dividing the bottom. So I'm going to do 328 times 6.02 times 10 to the 23rd over 1,000 times 32. I'm going to give y'all about a minute to put that in your calculator. Let me know what you guys get. It's a little bit of some complicated math, but I think that we can all do it and that we've all got it. All right, y'all have got about 45 seconds before we check our answers. About 30 seconds. Remember, let me know what answer you get in the chat so that we can all check our answers. All right, about 15 seconds. And if y'all have any questions in the meantime, type those into the chat, and I would be more than happy to work through them with you so that we can all better understand stoichiometry and chemistry. All right, 5, 4, 3, 2, 1. After putting that in our calculator, we get 6.1705 times 10 to the 21st molecules, which, using sig figs, since we started out with 1, 2, 3 sig figs, will end with 6.17 times 10 to the 21st molecule. Is the sig figs making sense to everybody? Did you guys get that answer? Let me know, and if everybody did, we will move on. If you're new, put those questions in the chat so that I can answer them for you. Welcome to the live stream. This is Chegg Stoichiometry Office Hours. We have a QR code in the top left that has the course schedule for all week if you want to see the other office hour offerings we have. But we are working through some problems I made, and I would be more than happy to take a break and answer your guys' questions. So let me know. All right, this one gets a little bit more complicated. Like Lawson from TikTok said, we are going to have to do some balancing of equations in this problem. So we have this chemical equation. It's a combustion equation, and we know that it's a combustion equation because we have something plus oxygen yields H2O plus CO2. I don't know if you guys have gotten into reactions yet, but if not, or if you have, this is what a combustion reaction is, and that's how to key yourself in that you're going to be having a combustion reaction. All right, so we are told that we start with 60 grams of C4H6, which is this right here. And we want to know how many grams of oxygen are we going to end with. I think this is supposed to be carbon dioxide. I think I wrote it wrong. So we're going to want to know how many grams of carbon dioxide will we end with. So let's balance this equation. That's our first step so that we can get a molar ratio, which is going to help us get from grams of one thing to grams of another. If you have a chemical equation and you need to get from something in that chemical equation to another, you always have to balance. Balancing is your best friend. You could solve the whole problem right, but if you didn't balance your equation, your whole answer is wrong. So always, always, always balance those chemical equations. So we start with C4H6 and we have O2. I'm going to put some blanks for where we're going to balance, and then we yield H2O and CO2. If you figured out how to balance it, let's see if you can beat me, but if you figured out how, put that in the comments so that we can check our answers and know if we're right, and try to beat me if you can. Balancing is a really good skill to have, and being faster at it is also a really good skill. So when I see these problems, I always, for balancing, start with carbons. That's my tip for you guys tonight. When balancing equations, start with your carbons. So I see I have 4 carbons over here, and I only have 1 over here. So I'm automatically going to make that coefficient 4. Now I go to my hydrogens, and I see I have 6 hydrogens over here, but only 2 over here. So I'm going to put a 3 right there. Now I'm going to tally up carbons and hydrogens on both sides and oxygens and see if they're equal. So I have 4 carbons over here, 4 carbons over here, check. 6 hydrogens over here, 6 hydrogens over here, check. And then I have 8 oxygens plus 3, so I have 11 oxygens, but oh no, it's not possible for me to get 11 here unless I do a decimal. So my trick with that is that I multiply the whole problem by 2 so that I get those nice even numbers. If you figure out you have to put a decimal, like in this case, to balance the right side of the equation, then you need to multiply the whole thing by 2 or 4 and get rid of that decimal. So I know my final balanced equation is 2C4H6 plus 11 O2 yields 6 H2O plus 8 CO2. And now I check and make sure again that I have the same on both sides because it's easy to get that mixed up. I have 8 carbons over here, 8 carbons over here, 12 hydrogens over here, 12 hydrogens over here. 6 plus 16, which is 22, and 22 oxygens over here. So I know that my equation is successfully balanced. Is that what you guys got? Let me know if it is. Now we have that molar ratio that's going to allow us to get from grams of C4H6 to grams of CO2. So I'm going to write down what I started with. And what I started with was 60 grams of C4H6. Now I'm going to go to moles because, again, this is a molar ratio, which insinuates that there are moles there, so I have to get it to moles. So I'm going to do grams to moles. And now what do I need for that? Anyone? We've talked about it a little bit tonight. What do I need to get from grams to moles? I'm going to give y'all about 10 seconds to put that in the chat. Right? We have 5, 4, 3, 2, 1. We need a molar mass. So we're going to find our molar masses of C4H6 and CO2. So for carbons, I have 4 carbons. And I know that my molar mass from carbon based on the periodic table is 12.01. So I get 48.04 grams per mole of carbon in this molecule. And then I move on to H's. I have 6 moles of hydrogens in this, and each mole has 1.01 grams per mole. So I get 6.06 grams per mole. What is that last step to find that overall molar mass? Does anybody know? I give y'all about 10 seconds to tell me what that last step is. 10, 9, 8, 7, 3, 2, 1. All right, so now we have to add that together. That's that last step. We have to add that 48.04 plus 6.06. What do you guys get when you add that together? All right, it should be 54.1 grams per mole. And while we are finding molar masses, let's find the molar mass of CO2. I'm going to give you guys about a minute to solve this on your own, and then we're going to come back together and solve it together. So once you get that answer, type it in the chat so that you can lock it in and we can check it all together. So y'all got about 45 seconds to figure out what the molar mass of carbon dioxide is. All right, about 20 seconds left. Come on, guys. I know you all can do it. Stoichiometry is easier than you think. If you're lost, let me know, and we will work through it slower and step by step. If you need something more challenging too, if this is too easy, let me know, and we will come up with something way more challenging. All right, 5, 4, 3, 2, 1. All right. From TikTok, we have someone that said 38. That is super close. So we have 1 carbon, and our molar mass, like we determined up here, is 12.01 grams per mole. And for oxygen, we have 2, and we have 16.00 grams per mole. We multiply those across, we get 12.01 and 32, and then we add them, and we get 44.01 grams per mole. So 38 was super close. My guess is that when adding them together, maybe you typed one wrong into your calculator, but you're very close to the actual answer. So good job from TikTok. So we now have our 2 molar masses that we need to solve this problem. We have 54.1 for that C4H6 and 44.01 for carbon dioxide. Both are going to be important. But right now, going back to our problem, we need the 1 for C4H6. So we determined 1 mole has 54.1 grams, and these are for C4H6. Now we need to get from moles of C4H6 to moles of CO2. So to do that, we can put moles of C4H6 on the bottom, because remember, what's on the top and what's on the bottom are going to cancel out. And on the top, we can get moles of CO2. So we have to, for this, we have to look at our stoichiometry, and whatever number is in front of those numbers is what's going to go in those blanks. So here for C4H6, I think I drew right on it. My bad, guys. But for C4H6, we have 2. So we put 2 as our moles of C4H6. And then for CO2, we have 8, like I circled right here. So we have 8 moles of CO2. So does that molar mass ratio, or not the molar mass, but does that molar ratio that we get from that chemical equation make sense to everybody? If it doesn't, let me know. We'll do some more practice here in a minute, or if you have any questions about it, let me know, and I will answer those questions or answer any homework help questions that you need. All right, so now our last step is we want to get to grams of CO2. So we need to go from moles of CO2 to grams of CO2. And just like we used and found over here, 44.01 grams per mole is our molar mass. So 44.01 grams is going to go on top. 1 mole is going to go on the bottom. And now we can solve that problem. So remember, we multiply the top, we divide the bottom. So we're going to do 60 times 8 times 44.01 over 54.1 times 2 times 1. I'm going to give y'all about a minute 30 seconds to figure out what that is. That's a lot of math, but I think we all can do it, so let me know what you guys get. Put it in the comments to lock in your answer. We have about 45 more seconds. $20 more seconds, guys. Lock in that answer in the comments. Bonus points if you can catch me making a mistake. Hopefully I don't make any mistakes, but let me know what you guys get. All right, 5, 4, 3, 2, and 1. If you got 195.238, you are correct, except there's one more step we need to do, and that step is, does anyone know? It is significant figures. So with whatever we start with, however many sig figs that is however many sig figs we need to end with. Trick question with this one is that this actually only has one sig fig. That 0 doesn't count since there's no decimal point. So our answer only needs one sig fig. And the way we would do that is we would just round up to 200 grams of CO2. Does that make sense to everyone how we got 200 grams? If that makes sense, comment. If you need more practice, let me know. And if you have any questions, any homework questions, any things you don't understand that you're learning in class, type those questions into the chat and I would be more than happy to answer them for you. That's what I'm here for. I want us to all learn something new tonight. Learn something new about stoichiometry, about chemistry, about science. If you have a question, let me know. And if you're new to the live stream, welcome, guys. This is Cheg's Stoichiometry Office Hours. We are learning all about chemistry, all about math, all of the fun stuff to some people. I think it's fun. And after this, hopefully you guys think it's fun too. But ask those questions so that I can answer them for you. All right, moving on to question 6. I always like these. These are kind of fun. They take a little bit of practice, but I think that you guys are going to get the hang of it after we do a few. We did one last week, so if you saw the one last week, help me through this one. Let me know what you guys get. But we're starting with 24 meters per second, and we want to get to feet per hour. So the way that we solve these is we pick one variable to solve for and we completely ignore the other, and then we solve for the other variable and we completely ignore the other. So we're going to start by solving for meters, and we need to get from meters to feet. So to do that, we need a conversion from meters to feet. Does anyone know that conversion? That one's a little tough, but I'm going to give y'all about 10 seconds to type that conversion in the chat, or if you need to do a quick Google search, that is fine too, but just let me know. 3, 2, 1. All right, we have 3.28 feet in 1 meter. You can kind of get that 3.28 feet if you think that a meter is close to a yard and a yard has 3 feet. So that's kind of puts into perspective meters to feet for you guys. So now we have successfully gone from meters to feet. We canceled out our meters. We ignored our seconds. Now let's focus on the seconds and ignore our feet because we have that feet right there. So we need to get from seconds to hours. Does anybody have any ideas on how to do that? I'm going to give y'all about 10 seconds to put that in the chat. So I know that you guys are learning. Let me know how we get from seconds to hours. All right, 5, 4, 3, 2, 1. All right. So we need to first go from seconds to minutes because I don't know about you guys. I don't know seconds to hours in my head, but I do know seconds to minutes and I know minutes to hours. So if I don't do those two conversions, I should pretty easily get from seconds to hours. So I put seconds on the top because seconds is on the bottom here and those will cancel out. Then I need to go to minutes because I know that conversion off the top of my head. So what is the seconds to minutes conversion? I know you guys know this one. Type it in the chat. What is the second to minutes conversions? 3, 2, 1. All right. 1 minute has 60 seconds. Good job, guys. Now I need to go to hours. So I put minutes on the top to cancel out minutes on the bottom. and hours on the bottom because I have hours on the bottom in my final answer. So I have 1 hour has 60 minutes, and then that will give me in my final answer feet over hours. So I know that all of my conversions are correct because I get what I need in the end. So now we're going to put that in our calculators. We have 24 times 3.28 times 60 times 60. And that is because I multiply the top and I divide the bottom. Since there's only ones on the bottom, I only have to multiply the top. I'm going to give y'all about a minute to put that in your calculator and let me know what you guys get, okay? Let me know what you all get when you put that into the calculator. Lock in your answer for me. All right, we're going to go for about 45 more seconds. Put that in that calculator. Let me know what you all get. And remember, if you have any questions, I'm here to answer them. So please type those questions into the chat. I would be more than happy to help you learn more about chemistry or stoichiometry. All right, we're going to go for about 30 more seconds, guys. Come on, I know you can do this. Yes, the stoichiometry is difficult, but with enough practice, we all have got this, and we're going to do good in our courses and really learn those things that we need to learn to get through college, to get through high school. We're going to go about 15 more seconds. 10, 9, 8, 5, 4, 3, 2, 1. Okay, if you are just now coming in, we are doing stoichiometry from chemistry. We're currently solving this convert 24 meters per second to feet per hour. So if you're confused, that's what we're starting with. But if you have any questions about chemistry, about stoichiometry in chemistry, type those in the chat, and that's what I want to help you all with. So type those questions. That's what I'm here for. That's what these office hours are for you guys to get personalized help with your problems. And this is the Chegg Stoichiometry Office Hours. We have sessions all week for different subjects, so I encourage you to join. But right now we are solving this 24 meters per second to feet per hour. The answer that you should have gotten when you put that in the calculator is 283,392. Now, remember, we have to do those significant figures, and whatever we start with is how many sig figs we're going to end with. So we start with 2 sig figs, and we're going to end with 2 sig figs. So if we round that, we get 280,000. And remember those units, feet, which we got from here, per hour. So 280,000 feet per hour. All right, as a reminder, ask those questions in the chat so that I can help you, and welcome to the Chegg Stoichiometry Office Hours. All right, now we are working on question 7. I wanted to do a little bit something new this week. I know we talked a little bit about moles last week, but mainly we focused on measurement changes. This week, I want to talk about molarity, dilution, M1V1 equals M2V2, all the fun dilution solution stuff. If you don't know what that is, ask me in the chat and I'd be more than happy. But if we all know what that is, I don't want to take any of our time learning about that. But if you do want to know, ask in the chat and I'd be more than happy to answer. So we are saying if 70 moles of oxygen are dissolved in 48 milliliters of solution, what is the molarity? So does anybody know the units of molarity? If you know the units of molarity, type those in the chat so that I know and so that everyone else knows too. We have molarity and then we have molality. I touched on this a little last week. Molality is more for powders and dry things. Molarity is more for solutions. So we're going to stick with molarity for right now. But the units of molarity is moles over liters. So moles over liters. Lucky for us, in this question, we are given moles and liters. So this is actually a pretty simple problem once you understand the concept of molarity. But what we're wanting to do is basically just divide that 70 moles of O2 over the 48 milliliters. And that value, oh, actually, I spoke too soon. Sorry, guys. Okay, so I said molarity is moles over liters. Our problem gives us 48 milliliters. So what do we need to do so that we can figure out the molarity? I know you guys caught it. You guys are smart. What do we need to do? Right, we need to convert our milliliters to liters. So we have 48 milliliters. We need a conversion from milliliters to liters. So milliliters are on the bottom so that they cancel out milliliters on the top. We know 1 liter has 1,000 milliliters, or as someone said earlier, 10 to the negative 3 liters is 1 milliliter. So we put that in our calculator. It should be 48 over 1,000. I'm going to give y'all 10 seconds to put that in your calculator so that you can let me know what you all get and lock in that answer. 5, 4, 3, 2, 1. Our answer is 0.048 liters. And if you are a little bit confused on where we're at right now, we are doing molarity. So we're figuring out how many moles of one molecule is in our solution. So how saturated is that solution? You know, we have different saturations of acid. A very strong, very high molarity acid is going to be way more harmful to your skin than a low molarity acid. That's kind of a practical example of molarity. So now we're going to plug this into our molarity equation. We have 70 moles of O2 over 0.048 liters. This is going to be a very high molarity, guys. Luckily, oxygen isn't too acidic or basic, so I don't think this would hurt anyone. But we're going to do 70 divided by 0.048. I'm going to give y'all 10 seconds to put that in your calculator. Let me know what you get. All right. 5 seconds. 3, 2, 1. You should have gotten 1458 molarity. That's a really high molarity. Normally, they're about anywhere from 0 to 50. This is a really high one, kind of just for practice, converting those milliliters to liters and catching those little sneaky things. But then we need to use our significant figures. So if you're new and you're wanting a little bit of a recap, we have been working on significant figures, which is basically just whatever we start with is the number we have to end with for good calculations and just good math and chemistry. Lots of teachers require sig figs. So all of our non-zero numbers are significant figures. So we start with 1, 2 sig figs. So we need to end in 2 sig figs. So that means we have to round our answer to 2 sig figs, which in this case would be 1,500. And when we use those 2 sig figs, we make everything else 0 so that they aren't significant. So our final answer for this is 1,500 molarity. And as a reminder, if you're just now joining in, this is for you guys to ask questions. So if you have any questions, I encourage you to type them in the chat. I see a message from Drew on YouTube. Can you go over naming organic compounds? So for this office hour, we are focusing on stoichiometry and chemistry. That's like basic level. But I do want to encourage you, this is a great time. If you see that QR code in the top left, those are all of our office hours for this week. And I know that there's an organic chemistry one. I'm 99% sure there's an organic chemistry one where I bet they are naming organic compounds using IUPAC. And so I would encourage you to check out that schedule and check out that organic chemistry office hour. And I think they'd be really great and helpful to answer your question. But now we're going to problem 8. Remember, if you have any questions, let me know those questions in the chat so that I can answer them for you. Our question is, if we want to dilute 6 molarity hydrochloric acid, so HCl is hydrochloric acid, to create 30 milliliters of 2 molarity hydrochloric acid, How much of the 6 molarity hydrochloric acid do we need? Does anybody have any ideas on how they would solve this? This is a pretty complicated and complex problem. Luckily, there's an equation for us that makes it easy, but does anyone know that equation? I'm going to give y'all about 30 seconds or about 15 seconds to put that equation in the chat so we can see if we have any overachievers who might already be ahead. All right, about 10 seconds. 5, 4, 3, 2, 1. Good job, guys. It is M1V1 equals M2V2. That's the problem we're going to use. So what this equation means is that the molarity of something times the volume of something equals the molarity of another substance times the volume of that substance. And why this equation is very helpful is because using that equation, we can figure out if we have all three of the other values, we can figure out molarity of something or volume or molarity of the other volume. So it's very helpful. The most confusing part about using this equation is figuring out what we have. So I'm going to color code it so that it's a little bit easier for us to see, but we know that one solution is 6 molarity, which is really high. Like we talked about earlier, the higher that molarity, the more harmful it's going to be to your skin. So if you have a really high molarity acid, that might burn your skin much more than a low molarity acid. So we know that we have a 6 molarity acid, and we also know we need to know how much of that 6 molarity hydrochloric acid do we need. So we're going to say this is our M1, and we're going to say we need to find our V1 because we need to find out how much do we need, how much insinuates how much volume, and volume is V1. Then we're going to find our M2 and V2. So our M2 is the other molarity, which is the 2 molars, and our V2 is that other volume. So we're going to now plug that in. We've got 2 and 2. So we are going to put our M1 is 6, just like we said up here, times, I'm going to plug in X because I think that X is just something that reminds me that I don't know what it is. Then we're going to have it equal our molarity 2, which we determined that to be 2. And then we need our volume 2, which is 30 milliliters. Now, for this equation, any volume, we can use any type of volume. It doesn't have to be exclusively liters or exclusively milliliters. We can use any type of volume. What's important, though, is that we just stay consistent. So if we have milliliters or liters on this right side, we have to be consistent, and we can't make this left side like inches cubed or something. It has to be the same. So if it's milliliters on one side, it's milliliters on the other. If it's liters on one side, it's liters on the other. They just have to be the same. So now this is a pretty simple problem. I'm just going to solve for X. I want to know what my volume is. X represents my volume, so let's solve for X. To do that, we would do 2 times 30 equals 6X. We divide by 6 on both sides, and we get X equals, what does X equal? I'm going to give y'all about 1 minute to tell me what X equals. All right, about 30 more seconds, guys. Let me know what X equals. Lock in your answer in the chat so we can figure out this dilution problem. All right, about 15 seconds, guys. And remember, we're about up to our time, but I do have time to answer 1 or 2 more questions. So if you have questions on homework, something you don't understand that you're going over in class, put those questions in the chat. I'd be more than happy to answer them for you guys. That's what I'm here for. I want to answer all of your questions. So use these last few minutes of our office hour time to really get your questions answered. All right, guys, time's up to answer that problem. If you said 10, good job. You are correct. So proud of everybody for learning tonight. So our answer is 10 milliliters. And that would make sense because if you want to have the same power as a lower molarity solution that's high in milliliters, you would need a lower amount of that high molarity solution. We're basically saying we want to get whatever is this side, whatever is the number of the left equal to the right. So if the left is 10, we want the right to equal 10 too. And if the left is 5, we want the right to equal 5 too. Good job from Mari on TikTok. You said 10. That is absolutely correct. I'm so glad that we are learning some stuff tonight. All right. Now, I want to do a challenge problem. So I don't know if this compound exists, but we are going to see how good with the rest of the time, if we have no more questions, but I would recommend y'all ask questions because I'd be happy to answer them. We're going to see how good your molar mass finding skills are. This is the challenge question. So I want to know, what is the molar mass of Ag2, Br, H12, C4O7. So I need to know, what is this molar mass? Since we focused on this tonight, I think everybody is pretty advanced in this now, hopefully. If you have any more questions, ask them in the chat. But can you guys find the molar mass of this compound? I'm going to give y'all about 2, maybe 3 minutes to do that. I'm going to start solving it on the board so that we can see if we're getting in the right direction, and you can have some help guiding you. All right, so I have 2 moles of Ag, and that is 107.86 grams per mole. I'm going to write out all the math I need to do first, and then I'll go back and I will solve. All right, now Br. What is the molar mass of Br? Does anybody know? It is 79.904. Fun fact. If you didn't know that, now you do. All right, what's our molar mass of H? We have 12 of those. It's 1.01. That's a pretty easy, nice one to remember. That's always my favorite. Sticks in the brain the easiest. Okay, what about carbons? That is 12.01. If you know these answers, guys, type them in the chat. Don't be afraid. All right, last but not least, oxygens. That is 16. All right, now let's put those all in the calculator. If you can put any of those in your calculator, type in the chat what your answer is. For the first one, I'm giving y'all 10 seconds. 5, 4, 3, 2, 1. It is 215.72. What is that next one? That's an easy one. 79.904. Anything multiplied by 1 is just itself. What is that third one? A little bit more complicated. And another key thing to remember is when we're doing these problems, we don't want to use sig figs till the end. And this one won't actually have sig figs since we didn't start with anything. It is 12.12. All right, what's that fourth one? 5, 4, 3, 2, 1. 48.04. And that fifth one, y'all got 5 seconds. 5, 4, 3, 2, 1. 112. And our last step. Does anybody know what we need to do last? If you said add, you are absolutely correct. I'm going to give y'all about 30 seconds to add all of that up. It's a lot of numbers. So I would definitely, if you have something like this on a test, solve it twice so that you make sure that you get the right one and you don't make a kind of silly calculator mistake. I've done that before, and it's annoying when you know what to do, but it's just a calculator mistake. All right. 5, 4, 3, 2, 1. If you got 467.784 grams per mole, you are absolutely correct. Hopefully you guys got that challenge problem. If you did, I'm so proud of you all. I really hope y'all learned something tonight. I'm about to the end of my time, but I do encourage you guys, look at that QR code in the left. If you want to get the course schedule for the other office hours this week, that schedule has everything we offer from organic chemistry. I think there's some algebra, maybe some calculus in there. Check that course schedule, see what courses are applied to you. And then these are great resources for you to learn that Chegg provides. So thank you so much, Chegg, for providing that to everybody. I encourage you to use those resources. And also, if you want more resources from Chegg, that QR code will work, or you can type Chegg in, and Chegg has so many great resources that help you learn and help you succeed in high school and college. I encourage you to tune back in next week. We're going to be doing more stoichiometry, more math, more chemistry, more challenge problems. Y'all can ask any question you want, and I would be more than happy to answer it for you. All of our other instructors would be happy to answer you too. So I encourage you to go to all of them that you can. But thank you so much, guys.